All right, let's take one more look at what happens when we compute rational powers of numbers. And we're going to do this entirely by hand now, because frankly, the calculator can do this for us. Our main goal here is to understand the structure of these rational exponents. Let's say I want to compute 125/8 to the negative 2/3 power. Now, just to be clear, I can punch this into my calculator just like this. It gives me a decimal. I convert it to a fraction. I know that the answer is going to be 4/25. My goal here then is not to find out the answer, but to understand why that's the answer. So let's see. Let's take a minute and understand a little bit more what it is to be negative 2/3. Negative 2/3 has three components. It has its negativeness. It has the numerator, and it has the denominator. For any negative rational number, we can write it this way. Or we could put it in any other order. Whatever order strikes our fancy. The way I'm going to go about computing by hand this power is to use the power of a power rule and compute in 3 stages. Let me show you what I mean. I don't like keeping writing the negative, so I'm going to deal with that first. Negative 2/3 is negative 1 times 2/3. What does the negative 1 power do? Well, it takes the reciprocal and then the first power. So that's just the reciprocal. That's a specific form of our general rule for negative exponents. So this will just be 8/125 to the 2/3 power. Now, I'm going to think about this a little bit carefully because, well, I could do the second power first, but I'm working by hand and I'm really not keen on multiplying 125 by 125. So I'm going to deal with the 1/3 power first and hope I get littler numbers. And I'd really like to take the cube roots of the numerator and denominator separately. Fortunately, I'm allowed to do that, right? Because I have this rule about power of a fraction is power of the numerator, power of the denominator. So I remember that this 1/3 power means the cube root. And now I make a short list of perfect cubes off to the side, right? 2 cubed is 2, 4, 8. 3 cubed is 3, 9, 27. 4 cubed is 4, 16, 64. 5 cubed is 5, 25, 125. Ah, there we go. So we'll have the cube root of 8 is 2. The cube root of 125 is 5. And now we just have to square 2/5. We're going to use this rule again. 2 squared over 5 squared. And we get 4/25. Again, we already knew that 4/25 was going to be the answer. But now we see why it works out this way. We're taking cube roots and then squaring. And somewhere in there we took a reciprocal. In general, I'm going to have some preferences. If I have an integer to start with, I'll use any negative 1 power last, because that's going to give me a fraction. If I don't start out with a whole number, I'll use it first. Maybe it'll give me an integer. Worst case scenario, I won't have to carry a -1 around, and that makes me happy. If it leaves me nice numbers, I'll use the 1 over q power first, because I like computing with small numbers. Now these are just general preferences. If following this order seems to make the problem harder, I'll pick something else. Let's see one more example, and then I'm going to give you one to try. Let's say we want to compute 1024 to the negative 3/5 power. Well, I definitely want to get smaller numbers as quickly as possible since I'm computing by hand. So I'm going to start by taking the 1/5 power. Notice I'm going to leave the negative right until the end because right now I have a whole number. So I'll have 1024 to the 1/5 to the negative 3. That'll be 5th root 1024 to the negative 3. All right, let's have a list of 5th powers. 2 to the 5th is 2, 4, 8, 16, 32. Yeah, am I going to count powers of 3 on my fingers? Not very high. 3 to the 5th? Well, 3, 9, 27, 81, 81 times 3. Let's write that down. Oh, 243. A lot of good that does us. 4 to the 5th? 4, 16, 64, I don't know, 64 times another 4, 4 times 4 is 16, 4 times 6 is 24, and 1 is 25. Times another 4, 4 times 6 is 24, 4 times 5 is 20, plus 2 is 22, 4 times 2 is 8, plus 2 is 10. There we go. Phew! 5th root of 1024 is 4. So 4 to the negative 3, that's going to be 4 cubed to the negative 1. 4 cubed, we said, was 4, 16, 64. And so we're left with 1/64. Okay, I'm going to give you one of these to try. I promise no 5th root of 1024. Compute 1/8 to the negative 7/3 by hand. Pause the video and try this now. All right, I have a fraction here, so I'm going to use the negative 1 power first. And I'm happy because the reciprocal of 1/8 is just 8. So that'll be 8 to the 1/3 to the 7th. So that's the cube root of 8 to the 7th. And I see that 2 cubed is 8, so I don't need to even make a list. 2 to the 7th. All right. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, that's the 5th, times 2 is 64, times 2 is 128. So this works out to, in the end, 128.